Hello everyone, and welcome back to the Fluctus Channel. The most feared supersonic bomber ever made is arguably the B-1 Lancer. It's distinguishable by its shape, most notably its wings, which change angles depending on the pilot's needs in flight. Called variable sweep wings, they are critical to this military aircraft's ability to operate at higher speeds and altitudes without encountering shock waves and drag that occur with straight wings. It took decades of insane evolution to perfect this design. That evolution began with earlier planes, like the F-111. The B-1 Lancer's variable sweep wings were developed to combine high-speed performance with long-range efficiency. Engineers designed wings that could sweep backward for supersonic flight and extend forward for stable, fuel-efficient cruising. This innovation allowed the bomber to take off from shorter runways while maintaining the ability to dash at Mach 1.2 when needed. Inspired by earlier swing-wing aircraft like the F-111, the system used powerful hydraulic actuators synchronized through computer controls. During testing, pilots confirmed smooth transition between configurations at varying speeds, solidifying the B-1's role as a versatile strategic bomber capable of low-level penetration and high-speed strike missions. Next came the F-14 Tomcat. Similar to its predecessor, the F-14 also has variable sweep wings, which allowed the aircraft to operate at both high and low speeds. The F-14 was the U.S. Navy's choice over the Air Force's F-111. With a slimmer design, it had the ability to roll and turn at supersonic speeds. In a dogfight, the F-14 would likely win out over the F-111. However, the F-14's payload capacity was much less than the F-111, The B-1 Lancer was conceived to merge the low-level strike capabilities of the F-111 aardvark with the supersonic agility and advanced aerodynamics of the F-14 Tomcat. Developed in the early 1970s as part of the U.S. Air Force's search for a next-generation bomber, the B-1 introduced one of the most sophisticated aerodynamic innovations of its time, the variable sweep wing. These wings could shift between 15 degrees and 67.5 degrees of sweep, allowing the aircraft to adapt seamlessly to vastly different flight conditions. When extended forward, the wings provided maximum lift for takeoff, landings, and long-range, fuel-efficient cruising at high altitudes. When swept aft, they reduced drag and increased stability during high subsonic and supersonic dashes, enabling the aircraft to penetrate heavily defended airspace at low altitude and high speed. The B-1's combination of powerful General Electric F-1 engines, advanced flight controls, and optimized thrust-to-weight ratio gave it exceptional takeoff performance, even from shorter or forward-deployed runways, a major advantage over earlier strategic bombers. During the Gulf War in the 1990s and subsequent conflicts, the B-1 proved itself as a reliable workhorse, capable of delivering precision-guided munitions with remarkable accuracy and endurance. However, as military technology advanced, its original analog systems began to show limitations. To extend its operational life, the U.S. Air Force initiated a series of modernization programs in the early 2000s, upgrading the aircraft with digital avionics, secure satellite communications, modern radar, and enhanced weapons integration. These upgrades transformed the B-1 into a more versatile and survivable platform, ensuring its continued role as a backbone of America's long-range strike capability well into the 21st century. The B-1's upgrades have continued into the present day, with the latest version of the aircraft, the B-1R, featuring improved engines, stealth technology, and other advanced systems. The B-1R is expected to remain in service for many years to come, continuing the legacy of this iconic and feared supersonic bomber. The history of supersonic flight dates back to the early 20th century when engineers and scientists started to study the physics of supersonic speeds. In 1935, a German engineer proposed the idea of breaking the sound barrier by using a rocket-powered airplane. But it wasn't until over a decade later, in 1947, when American test pilot Chuck Yeager became the first person to break the sound barrier in level flight in a Bell X-1 experimental aircraft. In 1952, the British made the first aircraft that could exceed 1,000 miles per hour. And the Soviet Union, in 1956, created the first supersonic passenger airliner, beating the British-French Concorde by 16 months. Supersonic flight has also played a critical role in military aviation, with numerous supersonic fighter and bomber aircraft developed over the years, including the B-1 Lancer. The B-1 Lancer has 4 General Electric F-1 turbofan engines that produce a combined thrust of over 130,000 pounds. To test these engines and ensure they are in good working order, the Air Force uses a special facility called a hush house. A hush house is a soundproof building designed to contain the noise and exhaust from a jet engine during testing. The B-1 engines are tested in a hush house before and after maintenance or repairs to ensure they function properly and identify any potential issues that may need to be addressed. During testing, the B-1 engine is towed into the hush house, where the engine is started and run at various power levels while technicians monitor its performance. The hush house is lined with sound-absorbing materials to reduce the noise from the engines. And it also features a ventilation system that removes exhaust gases from the building. It allows the Air Force to identify and address potential issues with the aircraft's engines before they become a problem. It ensures that the B-1 is ready for any mission it may be called upon to perform. Of course, these planes are not just made to fly fast. They need to carry bombs and other weapons safely. The design of bombers has evolved dramatically since the last World War. In the 40s, the B-17 Flying Fortress was the most technologically advanced heavy bomber used by the United States Army Air Corps. It was primarily designed to conduct strategic bombing missions against enemy targets, such as factories, airfields, and cities. The B-17 could carry a significant amount of weaponry, including machine guns, bombs, rockets, and even naval mines. Those mines could be dropped in the sea to damage or sink enemy ships. The B-17 also had an incredible ability to absorb damage and keep flying. It earned the nickname Flying Fortress. In the Korean War, the B-29 Superfortress became the go-to bomber. This one was designed to conduct long-range strategic bombing missions against enemy targets and could carry various ordnances, including 20 to 1,000 pounds of bombs, air-to-ground rockets, mines, and even napalm. When dropped on enemy targets, this highly flammable gel-like substance could create intense firestorms. The B-29's most famous mission was the atomic bombing of Hiroshima and Nagasaki in August 1945, effectively ending World War II. The B-29s that dropped the atomic bombs, named Enola Gay and Boxcar, were specially modified to carry and deliver the atomic weapons. Today, the B-1 Lancer is the bomber of choice for the U.S. military. Its ammunition is usually assembled and stored in a secure, climate-controlled facility, inspected and tested for quality and reliability. Once ready, the rockets, bombs, and more are transported to the aircraft, and trained ordnance technicians load them onto the B-1 Lancer with the help of machinery. This loading process can take several hours, depending on the type and number of weapons being loaded onto the aircraft. Before the B-1 Lancer is deployed for a mission, the crew undergoes extensive training, including bombing run simulations. During these simulations, the crew practices dropping bombs and missiles on designated targets, using both inert and live ammunition. The simulations are designed to replicate real-world conditions and help the crew prepare for the challenges they may face during an actual mission. During a bombing run, the B-1 Lancer approaches the target area at a high altitude and speed, and then descends rapidly to release its bombs or missiles. The aircraft is equipped with a sophisticated targeting system that allows the crew to precisely identify and track targets, even in low visibility or adverse weather conditions. Once the weapons are released, the B-1 Lancer quickly climbs and accelerates to escape the target area and avoid enemy fire. If the US military had to describe a perfect bomber, the B-1's design encompasses everything. Its wings allow the aircraft to perform at high and low altitudes thanks to their variable sweep design, and can be extended for lower speeds and increased lift, or swept back for higher speeds and reduced drag. This design enables the B-1 Lancer to perform a variety of mission types, including long-range strikes, close air support, and reconnaissance. Its ability to rapidly deploy and deliver precision strikes against high-value targets makes it a valuable asset in modern warfare. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.